Welcome to Maths for You YouTube channel. A past question on mechanics. A pebble is thrown horizontally at 14 meters per second from a window which is 5 meters above the horizontal ground. The pebble goes over a fence 2 meter height and d-meter away from the window as shown in the figure. The origin is on the ground directly below the window with the x-axis horizontal in the direction in which the pebble is thrown and the y-axis vertically upwards. So this is a projectile question and the diagram is given. Y-axis vertically, x-axis horizontally, and this projectile is purely under the gravity. So the acceleration used here is gravity, as gravity is perpendicular to the ground. So g meter per second squared. So it's horizontally is zero. There is no gravity horizontally. So if pebble is thrown horizontally, there is no vertical velocity, horizontal velocity, that velocity will maintain. Anyway, we'll the look at the sketch or diagrams given. Find the time the pebble takes to reach the ground. Find the Cartesian equation of the trajectory of the pebble, so the path of the pebble. Find the range of possible value for d. I just re-sketch the diagram. 5 meter, the window is 5 meter above the ground, and d-meter, there was a fence 2 meter height, and the pebble actually just going over that fence and reached the ground. So you just use the equation, sweat equation. Horizontally, there is no acceleration, so that is just to ignore it. S equal ut. So this S is a distance or displacement, if you want. The velocity, initial velocity, time. So S equal 14t. So we don't know S and we don't know t. Just keep that equation. Again, we can apply the Sievert equation vertically above the ground from the point where the window, so 5 meter above. So just use that again, the Sievert equation, h equal ut plus half gt squared. A is g squared. But when the pebble actually reaches the ground, it actually travel minus 5 meter. If we are using the vector equation above the ground, particularly upwards. Therefore, when the pebble reaches the ground, it's actually gone minus 5 meter, and of course there is no initial velocity. Minus half time 9.8, the g equal 9.8 meter per second minus 2, and t squared. From that, t squared equal 10 over 98, the 9.8, and t equal square root of 10 over 9.8, that is 1.01 seconds, that time. So the time taken to reach the ground from the window, the time is actually thrown from the window horizontally, and the time taken to reach the ground is 1.01 seconds. Then we have that equation 1, x equal 14t. So again, it's another what I did here. I just picked up on the path. I picked up a point. That point is its coordinates, or the horizontal distance and the vertical distance is x and y, and the time taken to reach there t. So the arbitrary functions. So if you are using the Survey equation vertically upwards, the distance travel, it's actually from the window, so minus phi minus y. It's just minus phi minus y, this distance. This distance is phi minus y. So it's below the window level, therefore minus phi minus y equal, again, vertically there is no velocity, it's 0, minus half times 9.8 t squared. So just to reach this arbitrary point, so 5, y minus 5, so I just move the minus sign inside, so 5, y minus 5 equal minus half 9.8 t squared, then y equal 5 minus 4.9 t squared. From that, we know the the x is use this equation here is this equation, x equal 14t, because of the horizontal distance or displacement is x at that point, 14t. That give us is x over 14. If you could substitute that value here for the y equation, or equation 2, y equal 5 minus 4.9 times x squared over 14 squared, which is, we could say 4.9. It's 4.9 is this is here. Here is 4.9. That is how we got 4.9. Here, just 14. We can actually write 14 squared as 7 squared and 2 squared. 7 squared is 49, 2 squared is 4. 7 squared is 49, and 4.9, 10 times is 4.9, and 49 is 10 times, so it's 10 here, and 4, so 5 minus 1 over 40 x squared. So we know the function on y, so the relationship between x and y. So when x equal d, y equal 2 meters, because of the at d distance, the fence and the pebble actually touching the top of the fence. But of course the given diagram doesn't give that. So that is actually that's what it is. So touching it. So just x equal d, y equal 2. Substitute those values. 2 is y equal 5 minus 1 over 40 d squared. From d that 1 over 40 d squared equal 5 minus 2 is 3. Then 3 times 40, that is 120. So d squared equal 120. D is plus or minus 120. So there's no minus business because of it's not the other side. It's one direction. It's a positive direction. It's a positive value. This one can be written as 4 times 30. So this is can be written as 4 times 30. Where is this? Here. That's equal. Sorry, just write it for some minus again. This is 4 times 30. 4 is the square root of 4 is 230. That is when you use a calculator. D is 10.95 meter. So that is what the first part is. The pebble takes reach the ground, which the time we have found, that's 1.01 second. To find the Cartesian equation of the trajectory of the pebble that we have found this one. And third one, find the range of possible value for D. It says possible value means it's when you do that, plus or minus, actual possible value is 10.95. Thank you. Please subscribe the channel and share the contents with your friends. Thank you.